So, ladies and gentlemen, we talked about the surface area, the lateral surface area of prisms. And we had prisms that looked just all like this. And we also even have, let's even say we did something like this. Even if you had a pentagon prism, right? It's the same thing because the base is the shape of the pentagon. Again, all you simply need to do is find the area of the base and the top, which is the same, and then find the area of every single one of your sides. For a rectangle, triangular, or of any type of regular polygon, you just find the area of the base and multiply that by 2 to include the base and the top, and then all the sides are a rectangle. What we found with a cylinder, which is a circular prism, is that to still find the area of the base, you multiply that by 2 because that's the base and the top, and then the sides was still a rectangle, but it had circumference, dealing with it. Now what we're going to be doing is finding the value of the volume. And the volume is going to be all the space that would take up. If you think about these as actually like open boxes and you're going to fill them up, the volume represents the space that's going to be inside. Where the lateral surface area was just what it takes to kind of create the box. Think of a cardboard box. The actual cardboard would be your lateral surface area. And then if you were going to fill that cardboard box with maybe packing peanuts, the amount of space that you can fill that up with is what we call the volume. So for each one of these figures, again, it's very important for us to be able to find or determine the base. For a rectangle prism, that's pretty basic because rectangles, remember, have opposite sides that are equal. So therefore, we can just always call this the base. That's basic. But remember, it's very, very important for us to be able to identify the difference when we have a triangular, any regular pentagon, or any regular polygon, or of a cylinder, what the base is going to be. Because we don't want to use, Asia, the base that's always how the polygon looks. We want to make sure we can draw it with whatever type of shape that we call it as the base. All right, so I'm going to make sure that I redraw them so that they look I'm going to make sure I draw them with whatever the special shape is of the base and the top is exactly the same. OK, Oscar? Yes? No? We can talk to Mr. Hodgkins if you want to. Now, we look at these figures, all right, and we see them. To find the volume, all right, which is going to be that amount of space, all we simply need to do is follow this one simple formula. Area equals base times height. You think area base times height, that's the area of a rectangle or of a parallelogram. And yes, you're correct. The parallelogram area equals base times height. Now, base represents the base of your figure, and h represents your height. This base is a little bit different, isn't it? Do you see the b how it's a little bit different? Yes? Because what b represents is the base of the the big B represents the area of the base. So what do I mean? Well, ladies and gentlemen, what's the area of this base right here? The area of this base is base times height, correct? Because it's a rectangle. Here, the area of this base is going to be 1/2 base times height, correct? The area for this base, if you look at it, is going to be pi r squared, because it's a circle. The area of this base is, remember, 1/2 a times p, your apothem times your perimeter, right? So when you're looking at prisms, you need to identify what exactly is the base, because the base can be different. You can have a rectangular base, a triangular base, a circle base, or you could have some type of regular pentagon as your base. So to find the volume, I'm sorry, that's not A. Jeez. Volume. To find the volume, all you simply need to do is find the area of whatever your base is, and then multiply it by how tall or how high your height is of your figure. Does that make sense? Huh? No questions? OK.